Hello all, welcome to the Engine channel. So today I will present to you a series of e-bike accelerators, different models that you can choose which one is more comfortable for you during the use of your e-bike. Basically, we have here three models of thumb accelerator. So this one is, let's say, in the vertical. This one is in the horizontal because we'll fix it by here in the e-bike, and then you will accelerate by here. Then this one is a little bit different. You just need to press. A little bit different of this one, thumb accelerator. And then finally we have this fish accelerator. Okay, this one have a key that is to turn on and turn off the e-bike. So this one is aggregated with the accelerator. This is common for some models of e-bikes. Okay, but what I want to present to you that is all have the same principle of work. Basically, all works with linear Hall effect sensor. This means that all will have three wires for the accelerator. For example, in this case, we have the red wire, the green, and the black. For standard, we have the red and black as the source, as the power supply, and then the signal that will change and send for the controller will be the green in this case. We have as well a different set of connectors. So what you need to pay attention when you're going to purchase your e-bike accelerator, if you want to change the model, or if you prefer just to replace for exactly one, you need to check your controller, because the controller that will be have the connections to the e-bike accelerator. Okay, so in this case here you need to check if the male or female, and then usually have the manual or indication in the wires which will be the accelerator connector. Okay, so for example, we have these two models here. So this one is the male and this one is the female. But for this one you can use, like for example, if you want to test, that is the objective right here, you can use this DuPont wire to make the connections. For example, in this case you just can connect by this way. Then you can connect to the power supply and make measurements to check how is the work of this accelerator. Okay, so, and in the other case, for example, this one is usually a connector with a waterproof. So in this case, if you want to purchase this one and your controller have a different connector, like this one right here, you can purchase a adapter like this one right here. For example, this one is the adapter for the LCD of e-bike because have more pins. So usually depend of the color, you know which one will be the number of wires inside the connector. For example, in this orange one we have only 3 wires, and after this you need to check if you want the male or female. In this case this is the male, so you need to purchase your controller, or the adapter need to be the female of this connector. Okay, so let's connect, for example, this one first, and then we can check for some measurements. And let's check with the multimeter about the voltage that we can have in this accelerator. basically the connector that will be responsible for the accelerator is this one, the black wire, red wire and green wire. So for this one I have adapter, then we can use this one for make the connection. So we can use this adapter right here. Basically is the female for make the connection here, and then we can make the connections to the multimeter. Okay, I will connect here, and then we need a power supply. In this case we will use a 24 volts DC power supply, this one here, that is connected to this connector right here. So I have the multimeter already connected in the negative, so I just need to make the connections for the power supply and as well for the reading of the output. In this case is the green wire, so I will make the connection here, and then the positive and the negative for the accelerator. So now the accelerator is already connected, so currently the power supply is already on. So we have a 4.89 volts DC without any throttle movement. So if we start to move the throttle, we will check that have some increment in the voltage, DC voltage, and then in the moment that I twist will be increase until the maximum, that is 19.5 volts. This is for a power supply of 24 volts DC. This could be different because usually the power supply for the accelerator come from the controller. So in this case we just checking that the linear Hall effect sensor inside of this throttle is working normally. So when we twist the throttle, we can see that there is an increment of the voltage, and then when we release, the voltage will drop until the minimum of 4.81. Okay, let's move for the other accelerator. Let's disconnect here, let's remove this one, and let's check for other one. This one is the thumb throttle as well. Okay, so for this one we can use this DuPont wire, so we can connect directly to the positive here, the green one in the middle, and as well we need one more, the black one, to be the negative. So making the connections. The negative, positive, and then we connect the output of the accelerator. So for this one we have 0.86 volts, and then when we try to increase, pushing the accelerator, we have the increment of voltage until the maximum of 12.5 volts DC. So this is, we can realize that the voltage will be different for each throttle. So in this case, despite we are using the same power supply, we have different voltage generator by the accelerator. For example, the other one start with 4.8 volts, and this one start with 0.8 volts. Okay, so let's check for the other one. Let's remove this one. So let's test with the other accelerator, with this one. So for this one is the male, so we can use this DuPont wire female for make the connections. So I will connect all at the same time. So as you can see, this one is similar to the other thumb accelerator. For this one we have the negative as a black wire, and the blue wire will be the output. Is a little bit different. So let's connect the positive. So let's connect the negative and then connect the output in the positive of the multimeter. So for this one we have the initial voltage of 6.9 volts. So when we press the accelerator we have the increase, and then increase until the maximum, that is 17.6 volts. When we release, we'll drop to the initial voltage of 6.7 volts. So for this one, let's try to disconnect, and as well let's open to check how is inside. So for this one, let me disconnect the wires here. So then we can open this accelerator. So basically there is a link here that we need to remove. This is for hold in the e-bike. Then we need to remove the screws. We have one here, other here, other here, and as well as you can see, this is divided in two pieces, and then this one need to be removed for be possible to open. So we can press here, and then we have the pin. So let's use this alicate to remove. So we remove the pin. Okay, then we can remove this part here, and then finally we have only one screw here, but this screw as well holds the spring here inside, because as you can see we have this movement, this backward movement that is due to the spring that is inside. So let's try to remove carefully, because it will be difficult to put the spring back. So let's remove carefully, and then let's try to open, but keep the trigger in the same position. Okay, now we open, so we can see that the trigger is just right here. So then we have this spring here. I will put back the screw here for do not release the spring. So the spring is inside here, and then we have the magnet here, and then the Hall effect sensor right here. Then we can see that there is no other components, is directly the wire soldered in each pin of the Hall effect sensor. Basically what we have here, when we push the trigger, we have the movement because we have a magnet right here, and this magnet will be change the position in front of the Hall effect sensor, and this will be cause the change in the voltage. Okay, so for example, here is the maximum position. So as you can see, the position of the magnet will change, and when we release, the initial position of the magnet will be the same as initial position. So let's remove the trigger here to see the spring. Okay, so here is the spring, as you can see, and then here we have the magnet. Okay, as you can see, there is some attraction between the screwdriver and the magnet. So to assemble again is not so easy, so because we need to lock in the beginning of the spring, so we need to put here, and then we need to fix in the other side of the spring. So to do this, we need to make some movement that is a little bit difficult. Because we need to put in the hole and then lock the spring and then turn until putting the back in the place. So after this, we can check if the spring is moving correctly. So if not, return back, we can see that something is not good, so we need to try again. It's because the springs did not lock as we expect, so we need to try again. Now it's okay because the spring is returning, is make pressure in the trigger to come back, so we need to push and then put the cover. And then put the first screw that is the responsible for hold the spring in the place. So once in the place, we can see that everything is normal. So we can put the other screws. Now there is detail that the big screw is in the top side. Now it's okay. And the last one here and here. Then we put this part right here, and then the pin. Here, and then the last screw is the Allen key. and finally is normal assembly. So that's it for this video. I hope that you enjoy and understand that all high-effects sensor is the same for all throttles. So basically what change is the position of the magnet. So due to this, we have different voltage in the beginning and in the end of the movement of the throttle. Thanks for watching. If you like this content, consider to subscribe, thumbs up, and see you soon in the next video.